To start with some punchline from Mammootty. He's my favorite actor. So, Kochi Palai Kochi Allah. Yeah, that's true because we have KCD happening in Kochi. Okay. So today we are going to talk about WebAssembly on Kubernetes. I just wanted to start with this slide actually. This tweet. This tweet is made by Solomon, who is a creator of Docker. He tells about the importance of Wasm and Wasi with the related to cloud native technologies actually. I mean, he tweeted this about 4 years back actually. If you see the current CNC of Wasm landscape, you can see a lot of growing number of applications and projects coming in this space particularly. So I just want to highlight few of them. Like if you see the hosted platform, currently a lot of companies bets on this technology like Cloudscaler, Fastly. They are providing a hosted platform to run your WebAssembly application in the cloud, in the production workload as well. And if you see the languages, a lot of languages started providing support for Wasm. And even your application development, you have a lot of frameworks now available like Spin, where you can straight away start your application development and deploy it in Wasm. So whenever you get a chance, I would suggest you to go to this list and check this landscape and get to know more about it. So before we get started, I'll give a quick introduction about myself. I'm Vanan. I'm working as an infra engineer in Arcesium. I have a keen interest in finding and solving problems in cloud native space. My hobbies are playing badminton, so I have participated in a few state and district tournaments. Badminton Palakkad is my favorite YouTube channel. If you want to watch some local tournaments, I think Badminton Palakkad is a good channel. You can keep an eye on it. So if you have any doubts, or you can always feel free to reach me out at @TamilHC in Twitter or LinkedIn. Okay. So the agenda for today's session is like I'll just give a quick overview of what is Wasm, how it works, and its security benefits, and then I'll deep dive on how you can deploy Wasm applications in Kubernetes. So Wasm and WebAssembly, this word I'll be using it interchangeably, which means the same. So let's get started. So you might be knowing, earlier days we used to install Photoshop or AutoCAD. We need to download the complete application and we'll be installing it in our machine based on your platform and running it. And later what happened, we can able to run those applications in our browser seamlessly without any lag. So we have all used that even for multiplayer game applications. So thanks to Wasm, those are the Wasm based application. We'll see how Wasm works actually. So in the right, if you see that tells you how a typical web environment look like. You have HTML, CSS or JavaScript or a framework which is developed on top of JavaScript. So these applications these languages are high level languages and very useful for developing your front end or your web applications. And it is not meant to solve a complex applications which is written in C or C++. You can't run that directly in a browser. So that's where Wasm comes into picture. Then you might be thinking, I can directly compile that C or C++ code and I can call it in a JavaScript, right? That's not true, because if you do that, like there are a lot of you need to isolate that application to have a set of access, right? So you can't directly compile and run your C or C++ code within a browser. You need to have a sandboxed environment. And also if you do that, the browsers are running in different platforms. It might be in ARM64 or x86 platform. So you need to have that platform independent as well. So that's the reason Wasm comes into picture. So usually you have your C code, which you will be compiling it and just running it as a binary. Instead, what we are doing, you will be having a tool chain to compile your Wasm application, compile your actual application into a Wasm module. It will be in a .wasm file. There are a lot of tool chains which supports that. Script is one of the tool chain which helps you to convert your applications into a Wasm module. Then from your JavaScript or your web application, you can export those Wasm modules and you can able to run your Wasm code or C++ application in a sandboxed environment within your browser. So we'll see how the Wasm code looks like. So it is more of a binary format. Like if you see the actual source code and the WebAssembly, it has a two format text or normal format is .wasm format that tells you it is a binary format. And if you see the left side, it tells you how close it is to your, it is an intermediate format. It tells you how close it is to your actual machine code. So when a browser or when a Wasm runtime executes the code, it has something called compile time streaming. On demand, it will able to compile that to a machine code. The translation is very lightweight and it happens at a near native speed. So that's the reason if you see there are languages like Python or Java, those interpreters also compile as Wasm. If you run as a Wasm, it will be more better near native speed compared to running as a normal Python interpreter. That's why there are a lot of languages also compiled into a Wasm module. So with that, I'll just talk about some of the security features available in Wasm. One is sandboxing. So when you run an application as a Wasm, right, it restricts direct access to syscalls actually. So with the Wasm module, you can't directly access the syscall within your host system. So it needs to access a wrapper API, but in case of browser, the browser provides you the API to access the host system to open a socket or access a file system. And also it runs in a memory safety environment. Basically your application is running in a memory isolated environment and it has a linear memory stack, so you don't have a buffer overflow and you don't have a few security advantages, like you don't have cell injections at all, because it restricts the indirect indirect function calls by default unless you have indexed those functions and you are not importing it. And it has something called capability based security. For example, let's say if you want to access a file system within your Wasm module just for read only as well, it doesn't allow that. You can't open a file like a system called open. It will be like open nat. You need a file descriptor to open a file, which means you already need to pre-initialize the set of files you are going to access. That way you can't arbitrarily access any file within your Wasm modules. These are some of the native security features which is available in Wasm. That's the reason people are considering Wasm for server-side applications as well. Let's deep dive how we can deploy Wasm in Kubernetes. That is a prerequisite to run Wasm application in Kubernetes. In the right, if you see, just now we have discussed how we can deploy an Wasm application in a browser environment. So basically in your JavaScript, you will be loading your Wasm module and your browser will run. So browser will provide you the sandboxed environment. It provides APIs to access the host system. So it provides you a sandboxing. But if you want to run outside your browser, basically in your server, you need something called Wasm runtime. Like our container runtime, you need something called a Wasm runtime. This Wasm runtime will implement the WebAssembly system interface, that is called WASI. Through WASI, you will be accessing your host access, for example, to open a socket or a file system. That you won't do a direct syscall. You will be going through the WASI. So that's why when you containerize the Wasm applications, right, you no need to have the host part. So basically, a normal typical application, when you Dockerize it or containerize it, you need to have that guest OS and then you have the system dependencies, right? But when you run your application as a Wasm module, you just need a scratch Docker image and just right away you can run your Wasm module. So that's the reason it is very small in size as well. We will discuss that in the later slides. So with that, I'll just give a quick brief on how our typical end-to-end life cycle of deploying an application works in Kubernetes. Basically, we all know you have a control plane that where you schedule your work. The user will schedule a work to the control plane. Then that comes to the worker node or a kubelet. Then it comes to the container D, which is our container runtime. That container runtime is the one which handles the complete life cycle of your the pod or container creation. Basically, it creates, starts, and deletes the container. But it doesn't do it by itself. It has a shim, which is runc that is the one which actually creates the namespace and C groups and run your OCI compliant container image. So it's how a typical Kubernetes environment will look like. So we don't want to alter this segment. We want to seamlessly integrate our Wasm application with the minimal changes, so that the end-to-end application deployment won't change much. So there are a lot of runtimes available in this space. Runtimes like Wasm time, Wasm, Major, Wasmer. Those runtimes helps you to run your Wasm module. So what we will be doing is like we will be adding those runtime as a shim. Okay, there are different reasons for multiple runtimes available. It is specific use cases. Wasm which is more useful on the edge use cases, and Wasmer is using a WASI-X, which is a superset of WASI interfaces. It has a fully POSIX equivalent support, but if you in case of Wasm time, right, it doesn't. Currently, we don't have a support for opening a socket, so it's still evolving. So that's the reason there are multiple Wasm runtimes are available. So basically, we'll be using those runtime and we'll be adding as a shim in a container D. So to add that, there is a CNCF project called RunWasi. Basically, it provides you a plugin to add your Wasm runtime as a shim in your container D as a separate handler. So there are two ways. You can directly register your Wasm runtime in your kubelet as a separate CRIO, but the managing the lifecycle, the end-to-end lifecycle, it differs. You can't use CRI-CTL command provided by containerd to manage your Wasm modules, but if you add it as a handler in containerd, I mean, the end-to-end, how we deploy the application doesn't change much. So once you have the RunWasi and is configured as one of the handler, and you will be mentioning which runtime to use. So for example, in this use case, I am taking Wasm time as a runtime. So you need to add the shim plugin, and then you need to register in your containerd toml configuration. So once you have done that, you need to add few manifests. There is a Kubernetes object called runtime class. By default, in general, we won't be adding the runtime class. It will take the default runtime class. Let's say you have a containerd that will be configured as your default runtime. But for specific reason, if you want to have a dedicated separate runtime, you need to register that runtime. So here in our case, we are configuring our Wasm time handler as a separate runtime, which is named as Wasm runtime here. And then if you want to have a dedicated set of nodes, in this case you can segregate a dedicated set of nodes for Wasm runtime, or if you want to run container D and Wasm side by side, you don't need to have those handler. So once you have registered this runtime class, when you create the pod, let's say your Wasm application, you need to mention this handler. So once this is done, it will be like typical application deployment journey, how you manage your existing deployments and applications. So that's how you can deploy Wasm applications in Kubernetes. And we'll talk about few of the advantages here. So when you compile a Wasm as a container, I'm mentioning that the size of your application will be very small. The reason is like you just have a scratch image, and then you have your straight away your Wasm module. So that's why the size is less. And coming to a performance, since it is an intermediate format, it can run in a near native speed. So that's why the performance is better. Since the size and performance is better, the startup time will be ideally it will be much lesser. That's why when you compile a application as a Wasm container, your application startup time will be milliseconds, and you can also able to run this OCI compliant image or the Wasm module as in your browser and in any cross-platform portably which has a WASI support or Wasm runtime supports that platform. You can able to run that in any platform. And as I mentioned earlier, the syscalls are managed through WASI. It is not a direct access. That's why you don't need to have any host or kernel interaction over there. That is handled through WASI. And image is supported in WASI and as well as the OCI compliant as well. So these are the few of the use case people bets on this technology, mainly for serverless workloads. So I was internally working on a data platform in my organization where in some use case I want to bring customer code on my environment. So I'm not completely aware what sort of application is it. So I was doing a POC on running those application as a serverless using my Wasm modules, and found that it is much more efficient, because when I was trying to run as a Knative a normal container, I need to do a lot of optimization. But with Wasm, without doing any of this, I can able to run the application in near native speed. And it is and also in edge and resource constrained environment, people are trying Wasm. Basically, I have a use case found in for a telco environment. People are trying to run their ORAN application in Wasm because it is much compact and better results actually. Even for if you want to run your local LLM with AI inference, I think since it has a better startup and performance, we can consider using it. So these are some of the use cases, and there are a lot to cover, like observability, altogether a different topic. Just a glimpse of what I have shared here. So that's it. That's the end of this session. It's a 15 minutes lightning session. So these are the reference materials I have used. You can take a note of it, and feel free to reach out to me if you have any doubts. I'll be around here till the evening, or you can always reach out to me through Twitter or LinkedIn. Thanks.